Imagine discovering a fossil so frustrating, so infuriating, that you name it after your own anger. In the world of paleontology, where Latin names honor heroes and describe ancient majesty, one dinosaur broke the rules. Its name wasn't chosen to celebrate its power or describe its appearance. It was chosen out of pure exasperation. Meet Irritator Challengeri, a creature whose very existence became a scientific nightmare before revealing extraordinary secrets. This isn't just another dinosaur story about teeth and claws and prehistoric dominance over ancient landscapes. This is a tale of deception, detective work, and a predator so perfectly adapted for hunting that it rewrote our understanding of how dinosaurs conquered water. The truth behind Irritator is stranger than any fiction. The fossil that fooled everyone. The year is 1996, and a package arrives at the Stuttgart State Museum of Natural History. Inside lies a skull encased in chalky Brazilian limestone, promising scientific treasure from the legendary Araripe Basin. This region in northeastern Brazil is paleontology's equivalent of striking gold, a place where fossils preserve with breathtaking clarity. But something feels wrong from the very first examination by the museum's expert preparators and researchers. The skull looks impressive, certainly, but details don't quite align with known anatomical patterns or expectations. Cracks run through the bone in suspicious patterns, and the proportions seem oddly theatrical, almost too perfect. As scientists begin their meticulous work, removing the surrounding rock grain by grain, the truth emerges slowly. This fossil has been tampered with, modified, deliberately altered before ever reaching scientific hands or proper analysis. Fossil dealers, eager to increase their specimen's value and visual appeal, have become creative sculptors. Plaster filled gaps where bone should be, reshaping the skull into something more dramatic and sellable. Pieces have been glued together incorrectly, creating false anatomical relationships that would mislead any initial assessment. The snout tip was missing entirely, lost to time, or perhaps removed during the modification process. Worse still, the entire skull had been compressed and distorted, making accurate measurements nearly impossible without extensive work. The scientists faced a maddening puzzle. Somewhere beneath this Frankenstein creation lay a genuine fossil of importance. But how much was real, and how much was artistic license taken by profit-driven dealers? Hours turned into days, days into weeks, as researchers painstakingly documented every alteration and began the process. When the time came to officially name this species, the lead researchers made an unconventional choice. Instead of honoring a colleague or describing a physical feature, they named it Irritator, a permanent testament. The species name, Challengeri, referenced Professor Challenger from Arthur Conan Doyle's The Lost World, a fictional scientist. Both the fictional professor and the real paleontologist shared one quality: profound frustration with their discoveries. This naming decision broke with centuries of scientific tradition, but it told an honest story. Paleontology isn't always about triumphant discoveries and clear answers. Sometimes it's about persistence through maddening obstacles. Irritator Challengeri would carry this legacy forever, a reminder that science requires patience when facing deception. Reconstructing the Predator. Despite its chaotic introduction to science, Irritator gradually revealed itself as something genuinely extraordinary and scientifically invaluable. As researchers removed the false additions and studied the genuine bone beneath, a remarkable predator emerged. This wasn't just another theropod dinosaur. This was a Spinosaurid, a family of specialized hunters unlike anything else. The skull measured approximately 60 centimeters long, narrow and triangular like a crocodile's deadly snout today. But this comparison only scratches the surface of its sophisticated adaptations for a semi-aquatic hunting lifestyle. Every feature told a story of evolutionary refinement toward a specific ecological role in ancient ecosystems. Its nostrils sat positioned far back on the skull, much further than typical theropods of the period. This placement wasn't random. It served a crucial function for an animal spending considerable time submerged. With nostrils set back, Irritator could keep its snout underwater while still breathing air easily. Inside the mouth, a secondary palate separated the nasal passages from the oral cavity completely and efficiently. This anatomical feature, common in crocodiles but rare in dinosaurs, allowed Irritator to breathe while gripping prey. Imagine holding a struggling fish in your jaws while still drawing breath. This adaptation made it possible. The teeth themselves were engineering marvels, straight or slightly curved cones with thin enamel and distinctive fluting. These weren't designed for slicing meat from bones like tyrannosaurs or tearing through tough hide. Instead, they were precision instruments for piercing and gripping slippery, struggling prey that fought for escape. A thin bony crest ran along the top of the skull, subtle compared to other dinosaurs' flamboyant displays. This feature likely served multiple purposes: structural reinforcement, muscle attachment points, and possibly visual signaling to others. In life, it might have been brightly colored, a flag identifying individuals across the lagoon. Perhaps most remarkably, Irritator's fossil preserved a stapes, a tiny ear bone rarely found in dinosaur specimens. This delicate structure offers invaluable insights into hearing capabilities and sensory processing in these ancient predators. Such preservation is extraordinarily rare, making this irritating fossil even more scientifically precious than initially realized. Size estimates place Irritator between 6 and 8 meters long, roughly 20 to 26 feet from snout. Weighing approximately 1 ton, it was modest compared to giants like Spinosaurus, but perfectly sized. This was a predator built for agility and precision rather than overwhelming power and brute force. The Aquatic Assassin. Understanding Irritator's anatomy is one thing. Imagining how it actually hunted is where paleontology becomes truly fascinating. Every bone, every tooth, every anatomical quirk tells part of a behavioral story written in calcium and time. Picture a warm, Cretaceous morning 110 million years ago along a Brazilian coastal lagoon's edge. The water is clear and shallow, teeming with fish that dart between submerged vegetation and fallen logs. The air hangs heavy with humidity, and pterosaurs circle overhead, their shadows dancing across the water surface. Irritator stands motionless in the shallows, water reaching halfway up its powerful legs and muscular body. Its narrow snout breaks the surface barely, nostrils positioned perfectly to breathe while remaining nearly invisible. This is ambush predation at its finest, requiring patience that could last hours without movement. Suddenly, a school of fish swims within striking range, unaware of the danger lurking so close. Irritator's neck muscles, incredibly powerful and specifically adapted, contract with explosive force and devastating speed. The head snaps downward and sideways in a blur of motion too fast for prey to evade. Conical teeth pierce through scales and flesh, the fluted surfaces creating a grip that tightens with struggle. The secondary palate allows Irritator to maintain its breathing rhythm even with a mouth full. The fish thrashes desperately, but escape is impossible. Those teeth were designed for exactly this scenario. But fish weren't Irritator's only prey, as fossil evidence dramatically reveals in stunning detail and clarity. One remarkable discovery shows an Irritator tooth embedded in a pterosaur's neck vertebra, frozen in time. This raises fascinating questions. Was this active hunting, with Irritator snatching flying reptiles from low flight, or opportunistic scavenging of a carcass washed ashore by storms and tides? The answer likely involves both strategies, showcasing the adaptability that made Spinosaurids so successful across millions of years. Irritator probably hunted whatever opportunities presented themselves, fish primarily, but also turtles, small dinosaurs, and carrion. In an ecosystem where resources fluctuated seasonally, dietary flexibility meant survival when conditions changed. Advanced CT scanning in 2020 revealed even more about Irritator's hunting prowess and sensory capabilities. Its brain structure showed elongated olfactory tracts, indicating a keen sense of smell for detecting prey. Large floccular recesses suggested precise head and eye control, essential for tracking fast-moving targets underwater. The inner ear structure indicated capability for rapid head movements without losing balance or spatial orientation. This adaptation, combined with forward-facing binocular vision, created a predator with exceptional targeting accuracy and coordination. Irritator could judge distances precisely, crucial when striking at fish distorted by water refraction and movement. Its hearing range, estimated between 350 and 3,550 Hz, fell somewhere between modern birds and crocodiles. This range would allow detection of prey movements, potential threats, and possibly communication with other irritators. Every sense was tuned for life at the water's edge, where land and aquatic worlds merged. Life in the ancient lagoon. To truly understand Irritator, we must reconstruct the world it inhabited, a lost ecosystem preserved in stone. The Romualdo Formation of Brazil's Araripe Basin offers an extraordinary window into early Cretaceous life approximately 110 million years ago. This was a time of dramatic geological change, reshaping the entire planet's geography. The South Atlantic Ocean was just beginning to form as Africa and South America slowly separated. This continental breakup created new coastlines, shallow seas, and isolated ecosystems where evolution experimented freely. The Romualdo Lagoon existed in this transitional world, connected periodically to the Tethys Sea, but often isolated. The lagoon ecosystem was remarkably rich in aquatic and aerial life, but strangely lacking in one area. Pterosaurs filled the skies in astonishing diversity. Fish eaters, insect hunters, and scavengers of every size imaginable. Crocodiliforms prowled the waters alongside Irritator, competing for similar prey, but likely targeting different size classes. Turtles navigated both water and land, their shells offering protection from most predators, but not all. Fish swarmed in schools, their abundance supporting the entire ecosystem's carnivorous population from above and below. Invertebrates, ammonites, crustaceans, insects form the foundation of this food web, converting plant matter into protein. But here's what makes this ecosystem truly unusual. Herbivorous dinosaurs were virtually absent from the fossil record. Unlike most Cretaceous environments where plant eaters dominated numerically, the Romualdo Lagoon was a carnivore's world. This suggests sparse terrestrial vegetation, perhaps due to poor soil or seasonal flooding that prevented forests. Without abundant plant eaters, carnivores like Irritator relied heavily on aquatic food chain for sustenance and survival. This dependence made them vulnerable to environmental changes affecting fish populations or water quality dramatically. Storms played a crucial role, washing fish and pterosaurs ashore, creating temporary feasting opportunities for scavengers. Different predators likely specialized to reduce direct competition for limited resources in this challenging environment. Irritator might have focused on medium-sized fish in shallow waters, while crocodiliforms hunted larger prey. Pterosaurs took aerial fish near the surface, and smaller theropods scavenged along the shoreline constantly. This ecosystem also reveals broader patterns in Spinosaurid evolution and global distribution across ancient supercontinents. Spinosaurids had already spread worldwide by this time, with spinosaurines like Irritator evolving in Gondwana. Their relatives, including the famous Baryonyx, inhabited Laurasia, the northern supercontinent, showing parallel adaptations. As Africa and South America separated, their Spinosaurid populations evolved independently, developing distinct regional characteristics over time. Irritator represents the South American lineage, while African spinosaurines like Spinosaurus itself grew to enormous sizes. These evolutionary experiments in semi-aquatic predation occurred simultaneously across thousands of miles, driven by similar pressures. The Angola Tuba mystery. No discussion of Irritator would be complete without addressing one of paleontology's ongoing debates and unsolved mysteries. Around the same time Irritator was being studied, another fossil emerged from the same rock formation. This specimen, named Angola, consisted of just the front portion of a snout and jaw. This fragmentary fossil showed distinctive features, a dramatic rosette of teeth at the snout's tip. These characteristics looked remarkably similar to what Irritator's missing snout tip might have possessed originally. Could these two different dinosaurs actually be the same species, just different parts of one animal? The debate continues today, with paleontologists divided into camps based on available evidence and interpretation methods. Some argue the anatomical similarities, geological context, and timing all point towards synonymy, two names for one. Others maintain that without overlapping bones for direct comparison, we cannot definitively prove they're identical species. This uncertainty highlights a fundamental challenge in paleontology, working with incomplete information and fragmentary evidence constantly. Unlike biologists studying living animals, paleontologists must reconstruct entire organisms from scattered pieces, sometimes separated. Every conclusion carries uncertainty. Every reconstruction involves educated guesswork based on comparative anatomy and physics. If Angola and Irritator are indeed the same animal, it would mean our understanding of this predator. The Angola holotype suggests some individuals reached 8.3 meters long, considerably larger than the Irritator specimen. This size difference might reflect sexual dimorphism, with males and females differing significantly in size. Alternatively, it could simply represent individual variation within a population, like height differences in modern humans today. The Irritator holotype shows unfused skull bones, indicating it wasn't fully grown when it died. Perhaps adult Irritators routinely reached sizes closer to the Angola specimen, making them more formidable predators. Some skeletal remains from the region suggest related Spinosaurids could have reached 10 meters in length. These giants would have been apex predators, capable of taking prey as large as themselves. The Romualdo Lagoon might have hosted a size range of Spinosaurids, from juveniles to massive adults. From a tampered fossil that infuriated scientists to a window into ancient aquatic ecosystems, Irritator's journey embodies paleontology itself. This annoying dinosaur taught us that frustration often precedes discovery, and that even damaged fossils hold extraordinary secrets. In naming their irritation, scientists created something honest and human, a reminder that behind every fossil lies not just an ancient creature, but the very human story of those who bring it back to life. From a tampered fossil to a predator that mastered aquatic hunting, Irritator's journey embodies the perseverance, curiosity, and meticulous work that define paleontology. In the end, both the fossil and the human story it tells are equally extraordinary.